Let us see what are the problems using pointers. Pointers are very dangerous when they are not used properly. And due to pointers, systems may crash, means our software or a program may crash due to runtime error. So at compile time we may not get the error, but at runtime we get the error. So runtime errors are very dangerous. Reason is, when we deliver our software to a client, when the user is using our program, there he may face the problem that during runtime, if the program crash, it gives bad name to a programmer. Getting an error at runtime at the user end is just like if a company is selling a car and the users are complaining about the problems in the car. So the car model will fail and they have to take away that model from the market. So the same thing may happen with the software. If our software is giving trouble to the user, then the users will avoid using it. So runtime errors are very dangerous. So we have to be careful with those runtime errors. And one of the major reasons for which we get the runtime errors is pointer. Now let us see what could be the possible problems using pointers. What could be the type of errors? Let us see. See, the first type of problem is uninitialized pointers. Uninitialized pointer, PTR I will write. Second one is a pointer may cause memory leak. And third type of problem is we may have dangling pointers. These are the three commonly known problems. Mostly these problems are caused due to the negligence of a programmer, carelessness of a programmer. Let us see the first one. Uninitialized pointer. So if you have declared any type of pointer, let me take integer only. If I have declared a pointer, then I should not use that pointer unless I have initialized it. Suppose I am saying star p assign some value 25. So this means that I want to store value 25 wherever pointer is pointing. But the question here is where the pointer is pointing. It is not pointing anywhere, just I have declared. Then what is the address in that one? So some default garbage address may be there, some random address that may belong to our program, may not belong to our program, right? So it is an invalid address. We have not made the pointer to point on some particular location, a known location. So first of all, make it point on some location, then you access it. Then how we can do that? So there are three methods of doing it. First method, if you already have some variable, say x, then you can say p assign ampersand x. I'll remove this. So now the pointer is pointing to this known variable which is already existing, already declared. So the pointer p is pointing there. This is the first method. So first method is pointer is pointing to some variable which is already existing. Then second method of initializing a pointer is to a pointer you can assign some address using some hexadecimal codes like 5, 6, 3, 8. Some address I have given. But this address has to be typecasted as integer pointer. So can we directly assign some address like this to a pointer? Yes, if we are sure that that address belongs to our program. So this type of initialization is also allowed. If required, we can use this. This is not commonly used. This is mostly used in systems programming. Then third one, to this pointer you should dynamically allocate some memory and assign to it. So I am taking an array of size 5. If I don't write size 5, just I write int, then it will allocate just one integer. So either to an existing variable or to the heap memory or the known address, you must assign a pointer. Without that, you should not use the pointer. Then after this, whether you store the value or read the value, it's okay. After any of these things, if you say cout star p, you will not get runtime error. You will get the data if at that place data is available. So this was the first problem, using uninitialized pointers. So sometimes programmers carelessly, they don't initialize and try to use it. So as a programmer, you don't do this mistake. Now the second problem is memory leak. This is related to a pointer as well as heap memory. Heap memory, as already I have discussed, that when you are allocating heap memory, then when you don't require, you should deallocate it. If you don't deallocate it, then we say that that memory is leaked from the total set of memory, total size of memory. Then if you continue doing that, you may run out of the memory. So Let us see this once again. I have a pointer and I have declared heap memory, allocated heap memory of some size, and I have used this memory. Then after some time I don't need it. So if I simply say p assign null, then pointer p will not be pointing on that memory. So suppose this is an array on which a pointer is assigning, and now we have removed this pointer from there. Null means we have removed the pointer from there. We should not do this unless we have explicitly deleted the memory. So first of all, say delete p, then only make p as null. Now here one more thing I have to tell you, that you can write p assign null, or else you can write p assign 0 also, or else you can write p assign null ptr. See, this means 0 only, and also you can write 0, but this is a literal, built-in literal in C++, like a keyword, reserve word. This is also 0, but it is not an integer value, it's an address value. So in modern C++, it is suggested you use null ptr whenever you have to write null. Avoid using null. So back to this memory leak. So the conclusion is you must delete the memory when you are not using it before making a pointer as null. Now let us move to the third problem, that is dangling pointer. Dangling pointer, I will show you one situation where this type of problem may arise. See, I have a main function, void main, I am writing here, and inside this I have a pointer, and to this I have allocated heap memory new integer of size 5. Then I have called one function. To that function I have sent a pointer p. Now this is function fun, void function fun, and which is taking a pointer as a parameter. And this function is using the memory, then after that it is saying delete q. Now see the situation. Main is having one pointer p which is pointing on some memory in heap. Then this p is given to q. Q is having a pointer in that function, so that is also pointing on same memory. Then after some time, at around the end of a function, it is deleting that memory, so this memory is gone. So who deleted that memory? Function fun, using pointer q, which was shared by main function. Main function has given this pointer to it. Now when the control come back here, inside the main function, if you try to access means I want to print some value, assuming that there is some value here, 7, I want to print that one, star p. Now p is pointing to a location which is not existing, the memory is deallocated, so actually this will cause an error, a runtime error. Pointer is trying to access the memory which is no more belonging to a program which is deallocated now. So this type of problems may also cause when you are trying to access the memory which is already deallocated. So this pointer p is now a dangling pointer. P is pointing on the location which is no more belonging to program. So uninitialized pointer means the pointer is never initialized. Dangling pointer means pointer was initialized but just now memory is deallocated. So we should avoid these three type of problems while writing programs or developing applications. Actually these problems are caused due to negligence of beginner programmers. The experienced programmers may check all these things thoroughly before delivering a program or before delivering a software, but beginner programmer may do these type of mistakes. So to make it simple for the programmer to avoid these type of dangerous errors, Java and .NET has removed pointers, and those languages are managed languages. So JVM will take care of all these things. It will try to deallocate the memory when it is not in use, and it will not allow dangling pointers to be accessed. So they take care in their own way. So that's why those languages are called as managed languages, and they are much simpler than C++. But C++ gives full control to the programmer. Now this is more powerful, but the programmer must be careful while using pointers. So I will give you a demo on this one. So practically I will show this.